Hello, hello. Oh, I think I've got sound now. Good morning. Okay, fine. So, it's a piece of green candy in my laser. Now, can you see the green sparkles in there? This light doesn't look smooth, it looks grainy. Those of you who have young eyes could try to defocus those sparkles, change the focal plane of your eyes. You will note that you cannot defocus the sparkles. Those of you with glasses on, remove your glasses. You will find that the sparkles are still in focus. The reason for that is that these sparkles are not here in the candy. They are on the back of your retina. That's an interference pattern. The light coming from the laser is coherent, all one color, all in the same phase. So the wave fronts interfere with each other, creating this nice sparkly effect. If you move your head back and forth, you will note that the sparkles move with your head. This is because your eyes are moving through the interference pattern. Isn't that cool? Think so? Our discussion today is about professionalism in software development. This is a talk I've given many times before, although there are bits of it that change from time to time. The purpose of the talk is to impress upon all of us the need for professional behavior. Our industry doesn't really know what it means to behave professionally. The definition of a software developer is someone who sits in a room, you throw meat in, and code comes out. And no one really understands how or why that happens. And we get very confused about deadlines and dates and estimates and all of the things that we're supposed to be doing, and we do them rather badly. Now, that's not unusual. Our industry is young. How many of you have been programmers for more than 10 years? Look at that. We got quite a crowd here. More than 20. Quite a few of you, I'd say about 5%, more than 30. Okay, we got maybe half a dozen. The next question is a much harder one. More than 40 leaves me. In most professions, you would find that there would be far more hands raised in the older crowd. Oh, there'd be plenty of hands raised in the younger crowd as well, but if you went to a convention of plumbers, the number of people who have been plumbers for 30 years would still be rather large. If you went to a convention of hardware engineers, electronics engineers, the number of people who would be over 30 years would be still fairly large. But in our industry, we see this cutoff at about 20 years. Now, that's growing. And if we came back in another 10 years, we'd find that the number of people who were 30-year veterans at programming would have gotten larger. There is a force in our industry that discourages older programmers. The idea is that you should have moved into management after 10 years or so, or even after 5 years. If you're not a manager after 5 or 6 or 7 years, something's wrong with you. And that's probably true. At least there's certainly something wrong with me. I have tried to be a manager a number of times. I have managed teams, I've managed groups, I've managed divisions, I've managed whole companies. But I'm still a programmer. It's what I want to do. It's what I like to do. It's what I'm happiest doing when I'm writing code, or if I'm on stage yelling at a bunch of programmers. That makes me happy too. And I happen to enjoy doing my videos, which is just yelling at a bunch of programmers through an indirect means. The idea that someone would remain a programmer for decades is rather foreign to our industry, but it's something that we're going to have to get used to, because there are a lot of us who would just rather stay programmers for a very long time and enjoy the process. And those folks will gather a great deal of experience and will help us define what professionalism is. The slide says that our craft is defined. 10 years ago, I would not have been able to make that statement. 10 years ago, we did not know exactly what it was that a programmer did, other than write code. But we couldn't define on a day-by-day basis what the process was, what the set of disciplines was, what the professional behavior was. Now we can. And that's because of something that happened about 10 years ago. How many of you are now doing agile development? Now, this is a remarkable number. That's probably over half of you, maybe over 2/3 of you. Most of you are lying without knowing it. But that doesn't matter. The notion that most of you believe you are doing agile development is fascinating. Agile development is a set of practices. It began, it began a very long time ago, but in earnest it began around 1998 or 1999 when Kent Beck published his rather controversial book, Extreme Programming Explained. Anybody read that book? It caused a firestorm. The industry at the time was immersed in waterfall. Who's still doing waterfall? Look at that, right? Hardly anybody. The couple of unfortunate people raised their hands without realizing that they're not supposed to do that. Hardly anybody does waterfall anymore, but 10 years ago, 12 years ago, that was what everybody was doing. It's what everybody thought they were supposed to do. We have managed to turn the industry around in 10 years, 180 degrees. That's a fantastic result. And in the midst of all of that, we defined a group of disciplines and behaviors, which I'm going to outline here, that define to a large degree what it means to be a professional software developer. But professionalism goes beyond simply following disciplines. There's an entire ethical topic involved here as well. What does it mean to be an ethical programmer? How do you know if you are being right? How do you know if you are defending your profession? That's an interesting topic as well, which we're going to discuss here along with the disciplines. I wear this green band. I've had this band or a band like it on my hand now for 6 or 7 years. I don't know exactly when it was. The woman who put it on me is named Elizabeth Hendrickson. She just walked up to me and handed me a green band and said, "Bob, here, wear this." And at the time, the band said "Test Obsessed," which is kind of her trademark. And it was a marketing gimmick for her company. I put it on, and I found that it took on a meaning, an ethical meaning. I couldn't take it off. Not because it was glued on, but because there was an ethical impact to having this band on my hand. The band said, I will follow the disciplines that I know. I will behave professionally. I will not do those things that I know are wrong, even though I'm put under pressure by managers and other people who have influence over me. I will not do those things I know I should not do. A remarkable effect that it had on me. If you want a band like this, you can get one at that URL. I don't take money for them. I do ask that you make a donation to a charity. I figure that if you're going to put something like this on, you should pay for it. But don't pay me. Give the money to some worthy cause, and then I will send you a band. One of the obvious disciplines that we learned starting around 1999, and why we didn't learn it before that, I don't know, is that things are best done in short iterations. Now, everybody here's doing Agile, almost everybody. So what is your iteration size? Who's doing 4 weeks? So a few of you are still following the old-fashioned Scrum thing that said 4 weeks. Almost nobody does this anymore because it was found to be too long. How many of you are doing 3 weeks? A few more. 2. Look at that. 1. Okay, I think we found the norm of the curve. The norm of the curve seems to be around 2. But if we had asked that question 5 years ago, it would have been closer to 3. If I'd asked that question 8 years ago, it would have been closer to 4. The mean of that number is moving to the small side. Come back in 5 years, there will be far more of you doing 1 week iterations. I know that seems impossible, but iteration sizes are shrinking every year. People have found that 4 weeks is too long. Too much can go wrong. You can get way off the rails in 4 weeks, and then it takes too long to recover. 3 weeks is too long. 2 weeks, okay. All right, we can do 2 weeks. 1 week. Not a lot can go wrong in 1 week. You can't make a big mess in 1 week. And if you close the feedback loop once a week, you can stay pretty close to the rails. Not Ruby Rails, Rails. You can stay pretty close to your goal. You can do quick course corrections. Now, of course, everybody says, yeah, but holy cow, if we're doing 1 week iterations, all we'll ever be doing is really planning and retrospecting and demoing, and we'll never write any code. No. All those meetings, the planning meetings and the retrospective meetings and the demos, they all get shorter too. You do a week's iteration, the planning meeting for a week doesn't take more than an hour. The demo, well, you're not going to get a lot done in a week, so the demo's not going to take more than an hour. Retrospective, what can you talk about after a week? Yeah. So, everything shortens up and you get a very nice cycle time. So, I'd like you to think about that. Short iterations are a moral issue. The shorter we make them, the more control we have over our process. The more accuracy we can get in our process. The longer we make them, the more can go wrong, but more importantly, the longer you can hide. If your iteration is a month long, you can hide for 3.5 weeks. 3.5 weeks can go by and no one will know that you've been surfing the web, doing some day trading, that you're just behind. No one will know that you're depending on someone else to finish the job for you. Has anybody ever worked at a company where you knew there were programmers who simply weren't doing anything? Or worse, doing stuff and you wished they wouldn't? Stop writing that code, because you're going to have to come in on Saturday and fix the mess they've made. Has anybody been the guy who comes in on Saturday and fixes the mess that everybody else made during the week? Okay, nobody wants to raise their hands on that either. I consulted for a company like that. They had about 40 guys working on code. 5 of them knew what they were doing. The other 35 made horrible messes during the week, and then those 5 would come in on Saturday and Sunday, and they'd make everything work. Right? One day, the manager, this is several years into this project, the manager finally said, this project's going too slowly. We need everybody working on Saturdays. And then nothing got done. Right? Short iterations go beyond just the iterations that we see in Agile. We do everything in short iterations. We write our code in tiny little iterations. We will write our code in periods that last perhaps 30 seconds if you're following a test-driven development cycle, something I'll be talking about a little bit later. We do everything we can in tiny little iterations because, frankly, we're not good at doing anything. So the more we check it, the more we close that feedback loop, the better we are at keeping on course. Has anybody ever had this lovely dream that you would be given a specification, you would take that specification and study it and internalize it, and then in a burst of insight and great creativity, the code would pour out of your fingers, and it would be perfect. You would hit Control-S for one and only one time to save that source file. You wouldn't even bother to compile it because you knew it would work. You'd check it into source code control, and everyone else would stare in awe at your mastery. That person does not exist. No such person has ever been able to do that. The best way to get anything done is to iterate in tiny little cycles. By the way, we're taught this from about first grade on. Who remembers the teacher who first told them that in order to write a story, you need to first write a rough draft? And this might have been in second grade or possibly third grade. And teacher says this, and I remember the teacher saying that to me, and my thought in my head was, what? I'm not doing that. What a waste. I'm just going to write this damn story. And I did. I just wrote the damn story. And in second grade, no one could tell, you know. But you get into high school, you get into the upper grades, and all of a sudden the teachers start kicking it back at you saying, what's this crap? They don't use those terms. They actually just use numbers. But you know what the numbers mean. There's some numbers that mean really good, and there's some numbers that mean crap. And you start getting these bad numbers, and you think, oh, what am I doing wrong? And maybe you go to the teacher and ask, what are you doing wrong? And the teacher looks at you and says, well, did you do a rough draft? No. Well, that's what you did wrong. And so then you start doing the rough draft, and then you do another draft, and you read it over. That's a little thing we learned after a while. Once you write something, it's a really good idea to read it. So you read it over, and then as you read it, you realize, this is awful, and you make some changes to it, and you do another draft. And as you get into college, that gets worse and worse. So you're doing draft after draft after draft. You're handing it to other people. Would you read this for me, please? Because I don't know if I'm doing any good. And you get this feedback and changes, and you finally hand it in, and people are going, oh, my, you did a very good job on that. And you realize that it requires this kind of constant iteration and feedback to do anything creative. Then you get your job as a programmer, and the rules completely change. You're expected to write it correctly the first time. You must now abandon all of that stuff that you learned about creative writing and iteration and rough drafts, and you just have to write that code the first time. And we are not taught, we are made to feel that any change to existing code is rework, and it's evil, and it's wasteful. It's not. It's part of the natural process. You cannot write the code correctly the first time. You have to iterate on it. Does anybody write their code and then read it? It's very depressing. You write the code, you actually get it working, then you read it and go, my God, I wrote that? Some of you will have that feeling. You'll go away to lunch. You'll come back and there's this code on the screen, and you look at the code on the screen and say, I didn't write that. That's not my code. And then eventually you learn, okay, fine. Another practice, never be blocked. This is an ethical issue. We sometimes get caught in this notion that this is my job, that's their job. And I'm waiting for something they're supposed to do. That means I can't do anything because it's their job and I'm not going to do it. It's their job. It doesn't work that way. Right? You can try to make it work that way, but that is a huge pathology, a disease of dysfunctional organizations. If you're waiting for something because some poor guy couldn't get it to you, do it. Go do it. Find some way not to be blocked. Or if you don't want to do it, find some way to isolate yourself from it so that you don't have to wait. Do not be blocked. The worst thing you can do as a professional is nothing. Is to sit and go, well, I can't work right now because Bob over there hasn't finished what he's supposed to do. Or that group over there, they haven't delivered their part of the bargain. They haven't delivered their module to us, so we can't work. I once was consulting for a team. The team had a set of QA people, 3 QA people who were supposed to be testing the system. And they were just sitting there. I said, you're not testing the system. They said, no, our QA system is not working at the moment, and the computer's not working, the server's not working, and we've called the people who are supposed to fix it, but they're busy, so we can't work. And I looked around the room, and there were all these laptops sitting on desks, because all the developers were at lunch. And I said, well, why don't you use one of those laptops? Oh, no. We can't use those laptops because they're not bona fide production environments. We can only do our QA tests on real production environments. I said, the programmers are testing their stuff all the time on those machines. Why don't you open up one of those machines and run some tests? If you find a bug, you can write it down. Oh, no. We have to wait. I was amazed at that attitude. That is an attitude that accepts blockage as though it were normal. Being blocked is immoral. It is wrong. It is unprofessional. It is irresponsible. It is something that you as a creative engineer ought to find some solution to. When you open up the top-level directory of your application, what do you see? Do you see directories that are named models, views, and controllers? Do you see top-level directories that tell you that you are in a Rails framework or a Spring framework or a .NET framework? If you were to look at that top-level directory, what would it tell you about the application that you were writing? Would it tell you what that application did? Or would it tell you what technology that application was using? I'm going to be doing a talk a little bit later, tomorrow I believe, called Clean Architecture. The idea behind our architectures is that a good architecture tells you what it's for, not what it's made out of. Many of us, if asked, what is the architecture of your system? We would say something like, oh yeah, it's Spring, Hibernate, Tomcat, with a lot of dependency injection. Or we might say, oh, well, it's based on .NET with an ADO backend, and we're doing a lot of link, and yeah, we got this view model thing that we're doing. Yeah, but that's not an architecture. That's a set of tools. The frameworks you're using, the technology you're using are a bunch of tools. They're not an architecture. An architecture tells you what the application is for. If I were to show you the blueprints of this building, you would look at those blueprints and you'd say, well, that's some kind of sports arena or convention center or something. You could see where all the bleachers were. You could see that big open area out there. You could see the area around the outside. And you would go, ah, that's some kind of arena. You would not say, looks like they used hammers and saws and bricks. You would know exactly what that building was for. The architecture of your system should scream at you. I am an accounting application. I am a trading application. I am a shipping application. The architecture should yell at you what it's for. The first time you open up those directories, you should look at that and go, oh yeah, this is some kind of some accounting application. Look, there's transactions, there's ledgers, there's credits, there's debits. This is an accounting application. You shouldn't have to hunt for that. What should you have to hunt for? You should have to hunt for the fact that it's delivered over the web. The initial architecture should not say, I am a web application. That's a detail. The fact that it's a web application is some nasty little detail. I don't want to know that it's a web application. You can tell me about that later. I'll hunt for how the damn system is delivered. I don't want to know web. I want to know that it's an accounting system. I don't want to know what database you're using. I don't want to know that there is a database. The database is a detail. Get it out of my way. I want to know what this system does. Do you know what the goal of a good architecture is, other than to announce to the world the purpose of the application? The goal of a good architecture, the goal of a good architect, is to delay as many decisions as possible. Defer decisions about frameworks and databases, web servers, and all those frameworks you're going to use. Defer those decisions. Get them out of the way. Make them late. The later you make a decision, the more information you have about how good that decision is. One of the big mistakes we make as software developers is we make a whole raft of decisions far too early. We say, oh, gosh, we've got to have a database. What database? Well, if this is .NET, we don't have a lot of choice, do we? Well, we'll use one, and we've got to have a framework, and we've got to have a language, and we've got to have all these things, and we make all those decisions, and then we start to write the code. Now, you got to pick your language early. But other than that, you ought to be able to write your business rules early and defer everything else for as long as possible. I'll have more to say about that later in my clean architecture talk. Anybody here got a mess? Bunch of code that you think is crap? Look around the room here. This is a large fraction of the room. Why is it a large fraction of the room? Because we've been writing a lot of crap. Why? Why have we been writing so much crap? Well, there's a reason. And it's not just down to carelessness, and it's not just down to rushing. Oh, rushing is certainly part of it. You know, we get into the mode where we've got a deadline, and we have to get this thing working, and we just forget all about the rules, and we spit this code out on the screen, and we think it works, and we hand it to QA, and we run home. And we've made a mess. But then later, something more interesting happens. Later, we come back, and we open up a module on our screen, and we look at that module, and we say, that's awful. I should clean it. And this, for a moment in your mind, you think, I'm going to clean this code. But then something else takes over. And the next thought in your mind is, I'm not touching it. Because if I touch it, I'll break it. And if I break it, it will become mine. Walk away from the code. And so we allow the code to sit there dirty, rotten. Our opportunity to clean it is gone. And we allow the entire system to rot. I will talk a little bit later today in this talk about a means to get around that problem. However, how do you solve it? Has anybody here ever told their boss, when the boss has come to them and said, how come it takes so long for you guys to do anything? You say, well, the code is a mess. The boss says, well, what are we going to do about it? And you see your opportunity. We could redesign it. Let's just rewrite it. If we rewrite it, we can do it clean and neat. We can throw away all this old crap. Let's just rewrite the whole thing. This is the great seduction. Everybody wants to rewrite the application. Everybody wants to walk away from the mess they made, leave it in the room where it's messy, close the door on that room, and never open up the room again. That's what we like to do. This is incredibly irresponsible. If you did that in your house, eventually you'd be out of rooms. Right? But don't go in that room. There's another reason why we don't do this. It's horrifically expensive. And what we have found is that these big redesigns just create another messy room. They don't actually clean anything up. You spend an immense amount of time and effort to get to the exact same place you were a year ago. What we need to do is face the fact that we've made messes and clean them. But you cannot clean them all in one great shot. You cannot clean things up with one great cleaning project. Please do not dedicate a month of your time to nothing but refactoring. Right? Instead, you just, every day, you look at some code and you clean it up a little bit. You do some random act of kindness to the code. If you follow a basic rule, always check the code in a little cleaner than when you checked it out. Always do some random act of kindness. Check out a module, do whatever you have to do in that module, then make sure it's just a little bit cleaner than when you checked it out. Check it back in a slightly cleaner state. If everybody did just that, the code base would just get gradually better and better and better. I'll talk a little later about a means to do that, but for now, no grand redesigns. Resist the temptation to redesign everything. The project is almost certainly going to fail. Oh, not a month-long one. A month-long will probably succeed. But a year-long redesign, man-years of effort into a redesign, probably going to fail. And it's fundamentally a flawed technique. It's irresponsible. Clean the damn mess up. You made it. Clean it up. And keep your code clean. Write clean code. Clean the code that you've written. Emphasize in your mind that it is unethical to write code that is messy. Learn the simple rules of clean code and then follow them, because in the end, the only way to get things done in a hurry is to do them right. Your grandparents taught you this. Your parents taught you this. It's an old saw. Everybody knows it. Anything worth doing is worth doing well. It is certainly true. And although we are tempted to rush and make a mess to meet some stupid deadline, we will actually meet that deadline better if we keep everything clean and do the best job we can. Has anybody here been slowed down by a big batch of messy code? That's everybody. What if the code were always clean? We could go faster. The lines would be shorter. We'd actually have fewer programmers. How many of you are practicing test-driven development? Hands up, test-driven developers. So this looks like about a third of you, maybe a quarter of you. What's the matter with the rest of you? This is a discipline where the jury is in, and was in 5 years ago, where the technique is well known to be very effective, that you can produce much better code by following it, much better performance. You get a lot of benefits out of test-driven development. So why wouldn't you practice this? Now let me describe it for you, just in case you weren't aware of what this is. Test-driven development is composed of 3 laws. The 3 laws sound stupid. Anybody who hears them goes, "He can't possibly mean that." So here's the first law. You are not allowed to write any production code until you have first written a unit test that fails. Now right away that sounds dumb. I mean, what test are you supposed to write? There's no code to test. So how can you write a test if there's no code to test? There's a whole bunch of arguments that you could go on about this. It just sounds stupid to write a test first. But the second law is worse. The second law says you're not allowed to write more of a test than is sufficient to fail. And not compiling is failing. Which means that you've got to start by writing a test, but you can't write more than a line or two, because instantly you're going to call some function that doesn't exist or mention some class that doesn't exist. So you have to stop writing the test before you're even begun writing it almost, and you have to start writing production code. And then the third law kicks in. The third law says you're not allowed to write more production code than is sufficient to pass the currently failing test. Which means that you write a little line of test code, and oh, that doesn't compile. And then you write a line of production code, and oh, that makes it compile. And then you have to go back to the test. Add another line to the test. Oh, that doesn't pass. You write some more production code. Oh, that makes it pass. And you're going back and forth between these 2 streams of code every 30 seconds. If you're a programmer of some years, and most of us in the room are, that just sounds stupid. I mean, why would you do that? Why would you interrupt your flow of thought by bouncing back and forth between these two streams of tests? Why would anybody do that? It would be boring, it would be tedious, it would be slow. You'd never be able to write a whole algorithm without bouncing back and forth. You'd never be able to focus on anything. It's all good points, all true. But imagine a group of people following these three laws. Pick one of them. Doesn't matter who, doesn't matter when. Everything they were working on executed and passed all its tests a minute or so ago. And it doesn't matter who you pick, and it doesn't matter when you pick them. Everything they were working on executed and passed its tests a minute or so ago. Maybe 2, maybe 5. But some very short time ago, everything worked. What would your life be like if you were never more than a minute or so away from seeing everything work? How much debugging do you think you would do? The answer to that is, well, there's not a lot to debug if it worked a minute ago. If it all worked a minute ago, and now it doesn't, it's something in the last 2 lines of code that I wrote. And the most common debugging technique is to hit Control-Z enough times to back away and then just retype what you wrote, because typically you just typed it wrong. Does that mean I don't use a debugger? No, I use a debugger. Every once in a while there are bugs that escape. Right? It's still software, it's still hard, I still use a debugger. I don't live in the debugger. How many of you are really good at the debugger? You know all the hotkeys, right? You are debugging God, right? You know how to do a step into and a step over. You can set 20 breakpoints here, wait for that one to get to it 10 times, then you get to this one 3 times. Now you watch that variable, wait for it to be a 37, and now you can debug. This is not a skill to be desired. You don't want to be good at the debugger. If you are good at the debugger, it means you spend a lot of time debugging. I don't want you spending a lot of time debugging. The debugger should not be your tool. It should be something that you use every once in a while because you know you screwed up. Not because it's, oh, I'm going to debug this now, and I'm really good at debugging. Well, that's a shame. I'm sorry you're good at debugging. I believe that if you were to practice those 3 laws, you could cut your debugging time by half, maybe more. And maybe you could think, well, that's a good reason to practice those 3 laws, or maybe not. Maybe that's not enough. So never mind that. How many of you have integrated a third-party package? So you get everybody, it's about everybody. Okay, so you get this zip file from somebody, and you unpack the zip file, and there's a PDF in there along with all of the DLLs and stuff that you need. And the PDF has got a nice little manual that describes the third-party package. At the end of the PDF, there's a little appendix area with all the code examples. Where's the first place you go? You go to the code examples. Why? Because you're programmers. You don't want to read the manual that some tech writer wrote. You want to go to the code. The code will tell you the truth. You'll read the code and go, oh, I see how this damn thing works. And if you're lucky, you can copy and paste the code out of the manual and put it in your application and fiddle with it to get it to work. When you are writing unit tests, you are writing the code examples for the whole system. If you're following those 3 laws, every part of the system will have a unit test. And that unit test will be a short little snippet of code, an example for how that part of the system works. You want to know how to call some API function? There is a test that calls that API function every way it can be called. You want to know how to create some object or set up some relationship? There are tests that do that every way it can be done. And those tests are short, little, unambiguous snippets of code. They are written in a language you understand. They are completely unambiguous. They are so formal they execute, and they cannot get out of sync with the application. They are the perfect kind of documentation. The perfect kind of low-level documentation. If you follow those 3 laws, you get massive, comprehensive, thorough, low-level documentation that cannot get out of sync, is utterly unambiguous. It's the perfect kind of documentation. If you like documentation, test-driven development will give it to you for free, or at least for the cost of writing those tests. But maybe that doesn't impress you, so never mind. How many of you have written tests after the fact? How much fun is this? It's not a lot of fun, right? I mean, you spend a lot of time writing the code, and that's the fun part. And then you have to test it manually and debug it. That's kind of the fun part, too. And then you get it all working, and then there's this rule that some guy wrote and says, well, you got to write tests now. Okay, test here, and all right, it says stupid rules, write a test there. And that part over there is going to be hard to test. And it's all kind of coupled into the code. I know it works. I'm not going to write that. I got other things to do. And so you leave holes in the test suite. Writing tests after the fact is something that you do almost under protest. And under protest, you leave holes in the test suite. You don't want to test everything. For crying out loud, you've already done it manually. When you write the test first, something else happens. First of all, writing the test first is fun because you're into the problem. You're specifying the problem. You've set yourself a challenge. Pass that test, you sucker. And now you will demonstrate your prowess as a programmer by making that test pass. Oh, I got it to pass. How many of you are programmers because you got something to run once and you want that feeling again? Right? You get that feeling all the time. You write a test. I wonder if I can make that pass. And then you write the thing that makes it pass. Oh, I got it to pass. All right, next test. That'll be hard. Oh, I got it to pass. You get this lovely charge every time. So the enthusiasm does not wane. It's not like this, oh, Christ, now I got to write a bunch of tests. There's a level of enthusiasm that stays up. And because of that, the test suite tends to be complete. Moreover, you're writing the tests first, and that forces you to design the code so that it can be testable. Another word for testable code is decoupled code. So you are going to decouple massively simply to get your test done. You'll have a better design. Okay, maybe that's not enough for you. Maybe you don't want to shorten your debug times, and maybe you don't want a stream of perfect documentation, and maybe you don't want a really good decoupled design because, well, you just think it's stupid to write tests first. But there's one other thing you get out of it. In fact, you can throw all that other stuff away. There's one other thing you get out of this. You get a suite of tests that you trust with your life. You get a suite of tests where you can click a button and see all those tests pass, and you know the system works. And when you have that, and then up on your screen comes some dirty code, and you think, oh, I should clean it, you've got those tests. So you try. You make a small change. Maybe I can change that variable's name. And you run the tests. Oh, they still pass. Maybe I can take that function and split it into two functions. Run the test. Oh, they still pass. Maybe I can take that class and split it up into two classes. Run the test. Ooh, something broke. Put it back. When you have those tests and when you trust them, you can clean the code. You will clean the code. Because suddenly the cost of changing code approaches zero. The risk goes way down. You've got a suite of tests that tells you it's okay, don't worry. I'll just make a little change here. Oh, the test still passed. This is so nice. Of course, the tests have to run quickly. Doesn't help you if the tests take 5 hours to run. So you need the test to run like this. That's a design challenge, by the way. I pose it to you as a design challenge. Keep your tests running fast. You're designers, you can figure out a way to do that. Software is a sensitive discipline. And by that I mean that if I have a binary executable that's maybe a megabyte long. How many bits are in that? 8 million bits. Small program. 8 million bits. How many of those bits could I flip from 1 to 0 or 0 to 1 and crash the system? And, well, there is one in there that will do it. But how many of those 1 bits are in there that will do that? Probably thousands. There are probably thousands of bits inside that 8 million, which if I just flip them from 1 to 0, will crash the system. Our systems are sensitive to failure at the bit level. Hardly any systems are that sensitive. You know, we could walk around this building and find some bolts and some girders, take a few of them out. The building wouldn't fall down. We could go out onto the highway and start removing bolts off the bridges. The bridges would stay up there for a while. Huh? We could go out drinking tonight and kill 10,000 brain cells, probably enjoy the process. Right? Humans are not sensitive at the 1 cell level. Bridges are not sensitive at the 1 bolt level, but software is sensitive at the 1 bit level. The only way to create correct software is to make sure that all 8 million of those bits is correct. That's hard to do. Most engineering disciplines don't have that problem. Most engineering disciplines live inside a robust world where there's room for error. We don't have that. What other discipline is similar to ours? Well, there is one. It's accounting. The accountants, they work with spreadsheets, and there are digits on those spreadsheets, not all of them, but certain digits on those spreadsheets, which if they get wrong, will take the company down and send the executives to jail. How do accountants prevent that from happening? Sometimes they don't. But how do they try to prevent that from happening? They have a discipline. That discipline is called double entry bookkeeping. They say everything twice. They enter every transaction, once on the debit side, once on the credit side, and those two transactions follow separate mathematical pathways until there's this lovely subtraction on the balance sheet that must yield a 0. If it doesn't yield a 0, something went wrong. If it does yield a 0, we hope nothing went wrong. It's possible that you could make complementary entries that gave you a false 0. That can happen. The odds are very unlikely. No judge would throw you in jail if you destroyed the company based on that kind of an error. When accountants enter their transactions, they enter it in the debit side, they enter it on the credit side, they get the 0 on the balance sheet, then they enter the next ones. They invented this 500 years ago, probably after a king started cutting off some heads. Test-driven development is double entry bookkeeping. We say everything twice, once on the test side, once on the production code side. We say them at the same time, just like they enter the transactions at the same time. And we do that for exactly the same reason. We have to get all our bits right. They've got to get all their digits right. We've got to get all our bits right. How can we, as professionals, treat our material, our code, with less respect than accountants treat theirs? Are they better than us? At the moment they are. But should they be? Is their stuff, are their spreadsheets more important to the company than our code? Why do they have a discipline like that and we don't? Or at least we don't follow it. Why is it that we thumb our nose and say, it's test-driven development stuff. Just let me write the code. Can you imagine an accountant saying, this double entry bookkeeping stuff, let me just enter the transactions. I'll enter them right. What a load of crap. Do accountants have a QA department that they hand their spreadsheets to? Here, we're done with our spreadsheets, QA. Now see if you can find any problems with them. Why do we have QA departments? Why has our industry invented an entire department to make sure that we don't screw up? Why? Because we screwed up. And our companies are going, what are we going to do about these developers? They're just pushing crap out to the door. And well, let's create another group, QA. They'll make sure it doesn't happen. And then you know what happens. The developers say, oh, we got a QA department now. That means I can meet any deadline. Give me a deadline. I'll check the code in by that deadline. It'll have some bugs, but that's their problem. I worked for a company once where everything was always done on time. Right? The schedule was perfect. Everything was always done on time. Sometimes a programmer would achieve his goal by checking in a blank source file. There was nothing in it, but he checked it in. Okay, check that off the schedule, and then QA gets it. Hey, wait, there's no code here. Well, that's a bug. Put that on the schedule to fix it on the bugs. That's not on the development side of the schedule. If you are practicing test-driven development or any kind of testing discipline, the goal is to cover the code with tests, to make sure that you have tested every line of code you write. Does it make sense to have any lesser goal? For example, should you be satisfied with 60% code coverage? Let's say you've got a tool that measures code coverage, and it says, oh, 60% of your code is covered. Is that good? A lot of us would look at it and think that's great. But what it means is that you don't know if 40% of the code works. Is that acceptable? No. What if an accountant said, 40% of our transactions are double entry? Yeah, there's 60% we're not so sure about. But 40% of them we're pretty sure are right. Isn't that good enough? No, of course it's not good enough. There is no meaningful goal short of 100%. If you're looking at code coverage, that's the only number to think of. How am I going to get this up to 100%? You never will get it up to 100%. That's okay. It's an asymptotic goal. But never fall for the silly line that says, you know, 70% is pretty damn good. No, it's not. It's awful. 70% is terrible. It means there's 30% of your code that you've got no idea about. This is the end result of QA. When you write a bunch of code, you hand it to QA, what should they find? Nothing. QA should find nothing. They should wonder why the heck they have a job. And that should be your goal. You should be looking over at those QA guys and going, you're not going to find anything. Next year, you won't be here. We'd like to take QA and have them do a slightly different job, actually, because having them work at the back end is an awful thing to do to people. Imagine that this is your job. You're going to, has anybody seen what the QA test plan looks like? There it is. Anybody seen the QA test plan? That's not the QA test plan. That's the table of contents for the QA test plan. The guy holding it out to me is the QA manager of a large internet travel organization. He's got 80,000 manual tests that he farms out to India every 6 weeks. It costs him $1 million every 6 weeks to run those manual tests. He's holding it out to me because he's just come back from a meeting with his boss, who just came back from a meeting with the CFO. And the CFO said, what the hell is this $1 million every 6 weeks that we're spending? And he's talking to me now saying, I just got my budget cut by 50%. Which half of these tests should I not run? I told him it doesn't matter. You can cut the document any one of a bunch of different ways. You're not going to know if half your system works. This is the end result of manual testing. Manual tests grow and grow because the features of the system grow and grow. And at some point, the effort required to execute those manual tests will become so expensive that some financial officer will spot it and say that must be cut. And you will lose your tests. It will happen. The only solution to that is to automate those tests. I don't want QA finding anything, and I want all the tests that QA writes. I want QA writing the tests, by the way. I want all the tests that QA writes to be executed automatically. I don't want any manual tests in the system. Manual tests are fundamentally immoral. That doesn't mean that you can't have people sitting there operating the system. I like the idea of exploratory tests, but I don't want them given a script. These are the tests you must pass. Imagine that's your job. You've got to follow that script. Has anybody looked at what that's like? Enter P9537 into the username field. Hit return. Enter QX723 into the password field. Click login. Did the welcome screen come up? This is your job. And you're going to repeat that every 6 weeks. One last. One of the things a professional learns how to do, and it's very, very difficult, is to say no. If your boss comes to you and says, we got to have this by Friday, and you know it cannot be done by Friday, you must say no. You don't understand. We must have it by Friday. No. Now, you understand that if we don't have this by Friday, we're going to lose a lot of money. I understand that. So will you get it to us by Friday? No. Well, why not? Because it's not possible. Well, can you try? No. You must never say that you will try. What behavior are you going to change because you said you would try? How will your strategy now be altered because you said you would try? How are the odds of succeeding made different because you said you would try? The reason you said you would try was to make him go away. And what he heard was that you would do it. And what you meant was, get out of my face. By saying that you would try, you told a lie. And that lie will come back, of course, because you won't get it done by Friday. And then they'll say, well, you said you'd try. Oh, yeah, I tried. Well, you didn't try enough. Thank you for your attention. I'll see you all at another talk.